Hi everybody, let's have a quick look at area and surface area as a bit of revision. To start with, area is the space within a shape on a two-dimensional surface, and the surface area is the two-dimensional space on the outer surface of a three-dimensional shape. In both cases, units are measured in square units. If that doesn't make sense right now, it's not really too much of a problem because we're going to go through it in detail through some examples. So first we'll look at two-dimensional area, and these are formulas that you should have learnt in primary school and lower secondary. So to find the space contained within two-dimensional shapes, it's critical to find the area of those shapes, and we use a group of area formulas, and you have to excuse my rather poor drawing of a trapezium down here. So starting with area of a rectangle, got my correct pointer, here we go, I've got my pointer. Area of a rectangle is length times width. Area of parallelograms, area base times perpendicular height. Make sure you get the perpendicular height, not the sloping height. Area of a kite is the diagonals multiplied together times by a half. Area of a triangle is area of the base times the perpendicular height. Be careful of this example. The base is along here, not the whole base, and the height is the perpendicular height, not the sloping heights. Area of a circle is pi r squared. Area of a rhombus, similar to a kite, multiply the diagonals together times by a half. And area of a trapezium, this length A plus this length B, halve it, times it by the height. And we have all the two-dimensional areas. Now we have to be a little bit careful. When we're drawing three-dimensional shapes, we distort the image to make it look three-dimensional. And even though this here looks like a parallelogram, it's actually a rectangle. So I've drawn the distorted images here. The left and right looks like a parallelogram, but it's actually a rectangle. Some students will not be able to see the rectangles, and if that's the case, you really have to be careful when you've got a prism image that you use the right formula. On to surface area. Now when we have surface area images, especially drawn in two dimensions, there are hidden faces. So we have a front face here, but we also have a back face, a right face and a left face, a top face and a bottom face. So if we forget one of those faces, we'll get the surface area wrong. Now, even if the faces are hidden, we still have to count them. Cubes are an interesting one because all of the edges are the same length and typically we'll only be given one edge. So if we're looking for the area of the front face, we know that this length is 3, but we also know that that length is 3. And 3 times 3 will give us 9. And because all of the edges are the same length, we can multiply, not all the edges, all the faces are the same area. And there's 6 faces, we can multiply the area of the front face by 6 to get the total surface area. And that's a common technique that we'll use when determining surface area of a bunch of different shapes. If we have 2 faces that are the same size, we'll calculate it once and then multiply it out by the number of faces the same size. So let's work it out. Area of the front face would be 3. Area of the front face would be 3 times 3, which will be 9. And we have 6 of those, so we'll multiply 6 by 9 to give us 54 units squared altogether. That's 6 equal size faces of area of 9 units. I have to be careful always to write our squared units in, because we're not measuring lengths, which would just be units on its own. We're measuring the amount of space inside a face. That even rhymes. So let's try a rectangular prism. This length 2, this length 3, that length 6. The front and back would have an area of 2 times 3, which is 6 units. The left and right, so this part here and the hidden face on the other side, will be 6 times 2. And the top and bottom will be 3 times 6 to give us 18 units squared. Now when we do this, we have to make sure that we have 2 of these and 2 of these and 2 of these. So I've used distributive law here because I'm lazy and I just want double whatever the area is of the single faces. Front, left and top, multiply that by 2, I'll get back, right and bottom. And that's what I've done here. So 6 and 2 is 18, plus 18 is 36, and I've got 2 lots of 36, which is 72 units squared, is the surface area of my prism. Here I've got a trapezoidal prism. It's a trapezium on the front. So I'll have a trapezium on the front and on the back. I'll have a top, I'll have a bottom, I'll have a left, I'll have a right. The top is not the same size as the bottom, so I can't just multiply it by 2 this time. So here's the top, that's that one there, 2 by 6. Here's the bottom, 8 by 6. The left and right are the same size, so I'm going to be able to multiply that by 2. 5 times 6, and the front and back is a trapezium. 2 plus 8 is 10, divided by 2 is 5, times 4 is 20. That's what I've done here. Now to work out the surface area, top, bottom, 2 times my left and right measurement, plus 2 times my front and back measurement, 60, 60 is 120, plus 40 is 160 units squared. When we get to more complicated shapes, we have to be a little bit considerate of how to calculate them. In the case of a cylinder, we've got a top and a bottom, and we've got a curved side. The way we find the curved side is the curved sides, if we cut it and then consider the length of it, it'll be the length of the circumference of the circle at the top. If you haven't seen a teacher do this, ask them and they'll show you. It's really easy to do once you know how it works. So we'll have a circular top and bottom, and then we'll have this rectangle to represent the curved sides. Here's an example. Radius 2, height 5, they're all the measurements you need to work out the surface area of a cylinder. The top and bottom will be 4 pi units squared, pi r squared, radius of 2, 2 squared is 4, 4 times pi is 4 pi. The curved sides will be the circumference times by the height. The circumference formula is 2 pi r, 2 pi times 2, which funnily enough is also 4 pi, times 5 is 20 pi units squared. Then we add those two together, making sure that we've got 2 of these. So there's 1, there's the bottom, there's the curved sides, 28 units squared. Brilliant. Here's an irregular shape. So we've got a half cylinder on the top, and we've got a rectangular prism on the bottom. Now, when I'm doing problems like this, I might make some dot points to say what I need to do. So the top of the box is hidden, so we can't count that, and we only need half of the cylinder. So here's the bottom of the box, 6 times 10. The left and right, 5 times 6. The front and back, the left and right, oh yeah, front and back, 10 times 5. There it is there. Then we can look at the cylinder. We're going to need half of the cylinder, but we'll calculate all of the cylinder and half it at the end because that's easier. Top and bottom, the radius we know from here, if that whole width is 6, half of it's going to be 3. Pi r squared, 3 squared is 9, 9 pi units. The curved surface, the circumference times by the height's 10, the radius is 3, 2 pi r, 6 pi. So that'll be 60 pi units squared. Now we've got all the individual measurements, we just have to put them together into the surface area. Bottom, 60. Left and right, the left will be 30, plus the right will be another 30, so there's 60. The front and back, 2 lots of 50, which is 100. Half of the cylinder, top and bottom will be 18, plus the curved surface will be 60. Looks okay so far. 220 plus half of 78. Half of 78 is 39. So it'll be 220 plus 39 pi units squared. If you want to know an exact measurement, you could use your calculator to work out what 39 pi is and add that to 220. The last thing we need to probably consider is when we have a cutout, because cutout will have our normal shape and then we'll have some additional faces exposed. So in this case, it's like a cheese slice. We've cut a bit out of a round of cheese. 3/4 of it is still there, a quarter is missing, and it's exposed to rectangular faces. So working out the surface area of the whole cylinder would be the top and the bottom plus the curved side. So the top and the bottom will be radius of 4 times pi, need to square the 4. That'll give us 16 pi units squared for the top. We need another one of those to make the bottom. And the curved surface will be 2 pi r, 2 times pi times 4, which is 8 pi times 6. 6/8 of 48 units squared for the curved surface. And then we have the two cut faces, the 6 height plus the 4 width. And we've got 2 of these. So there's the 2 times 24 for the cut faces. The top and the bottom, we'll need 2 of these, which will be 32 pi, plus the curved bit, which is 48 pi, which will give me 80 pi. 3/4 of 80 pi is 60 pi, plus our 2 times 24 is 48. So the answer would be 60 pi plus 48 units squared. Now, surface area can be quite difficult. So if there's some concepts of this that you're finding hard, have another watch. And I highly suggest doing some more practical examples. There are some on Connect if you're in my class. Thank you, everybody. That was a bit long.